So let's see if my screen comes up. Oh, yeah, that is my screen. So my name is Paul, and I am the world's second worst Java developer. So unlike many of my colleagues, I will not be starting at start.spring.io. I will be starting right here. So I've got a few things I want to talk about. Obviously, Kubernetes is a big part of that. Thankfully, we've already covered a couple of Kubernetes-related items just before, like the reconciliation loop. So that will let me go a little bit faster and hopefully regain some time so we get out to lunch as quickly as possible. Because I don't know about you guys, but I run on food, so getting to lunch on time is always good. So this is me. I have been introduced. This is Kubernetes. You've kind of met Kubernetes already. A friend of mine, Corey Quinn, says that Kubernetes is the named after the Greek god of spending money on cloud services. And if you've ever used Kubernetes on one of the clouds for any amount of time, you'll notice that that is absolutely true. It is a very good way to accelerate how quickly you can use servers and VMs, which definitely increases your spend, but hopefully in a good way, because hopefully you're getting value. I'm going to skip through a few things. So who here has used Docker before? I'm hoping we're going to see most hands up. So quite a few of us. Okay, good. So I can kind of skip through that. You've probably all seen a Docker build file. This is a multi-stage Docker build file, which is essential for making smaller Docker images. So you can see I start with a full-size JDK image to do the Maven install. But then I copy the resultant jar file into a smaller JRE slim image. And this allows me to get a Java image that is only about 200 meg versus around a gig, which helps a lot because with Kubernetes, you end up pushing and pulling images a lot. And it can take some time if you're having to do that with like 1+ gig images. So doing this is pretty important. There are other tools in Java to do image builds. There is the Java image builder from Google, and that's really useful because you don't actually need Docker installed on your machine or on your build machine. It sort of knows how to construct a Docker image and does it behind the scenes, and that's pretty useful. And it will also push it straight up to a Docker registry, so it's immediately available to Kubernetes. And that will also build quite a small image. So we're really trying to build small images so that we can really make efficient use of Kubernetes. When you're working with Docker, you're running commands like this. These are very imperative, and I'm giving very specific commands: build, push, pull, run, etc. And that's great when I'm working on my laptop here. It's not so great when I am working in a data center where I have maybe hundreds of servers and maybe thousands of containers. And so I need that container orchestration, which is where we get to Kubernetes. And this is what Kubernetes looks like from my perspective. I am a platform operator. I come from a systems administration background. And so this is the stuff I'm interested in. But the only thing we really need to talk about in this is the two things up in the control plane called the controller manager and the cloud controller manager. So controllers are the things in Kubernetes that create those feedback loops that we were just talking about, which basically look at when you ask Kubernetes to do something for you, that's considered to be the desired state. And it stores that in a database, and it's constantly looking at the actual state and making sure that it matches that desired state. And if it doesn't, it performs actions to try and remediate it to make the actual state look like the desired state. And controllers generally follow that do one thing and do it well philosophy. So they tend to be quite small. I've written controllers that are like 40 lines of Go code, so you can make them quite small. And then you can combine them together to do very powerful things. And we will show a few of those things in a second. You interact with Kubernetes using this command called kubectl or kubectl or kubectl, depending where you lie on that debate on how to pronounce it. I really don't care how you want to pronounce it. I usually say kubectl, but say whatever you want. And you can pass it commands that look very similar to those Docker commands earlier. So I can say kubectl, go run this thing for me. Kubectl, scale this for me. Create a service, etc. And so these are imperative commands. And so if I run that top command 4 times, I will have 4 deployments called hello from that hello image. And that's not necessarily what I want to do when I'm running things in production. So what I can do is I can provide a Kubernetes manifest, and I'll show you what they look like in a second. And that Kubernetes manifest is basically a YAML or JSON file that describes my desired state. And I pass that to Kubernetes, and I let Kubernetes figure it out. And I can then store that YAML file in source control, and it becomes my configuration as code. It becomes that thing that I can start doing continuous integration, continuous deployment, and follow like a GitOps style workflow. So this is how you want to do it when you're actually looking to run things for real. But the imperative commands are great for demos and for quickly testing things out. So there is a place for both. And I will be mostly working with the imperative commands when I do some demo. So yeah, go for it. Go for declarative if you're doing things for real. Kubernetes manifest looks a little something like this. They're actually a lot more complicated, but for the sake of fitting on the screen, I've just put the bare minimum in. So this is calling for a pod. It has some metadata, and it has a spec. And that spec is basically a literal representation of the API spec that it's expecting. And obviously, this is very small. The actual API spec for a container is much bigger, so it just fills the rest in with defaults, which are usually fairly sane. And so if I was to pass this to Kubernetes, I would actually get a working copy of this application. And so now let's talk about pods, service, and volumes. So they're kind of the three most common Kubernetes resources that you will use. There's actually a lot more than that, but you can kind of get most applications running with the three of these combined. And I'm going to kind of demonstrate these. Well, first of all, talk a little bit about pod. It's kind of the execution environment for your application. And it is not just one container. It can be multiple containers, but they share a network IP address, and they share storage. And that allows you to say you have, God forbid, a PHP app, which is 2019. Why do you have PHP apps? You can run an Nginx container and a PHP FPM container in the same pod, and they can communicate over a socket file or over a network, over like a local host. You wouldn't, however, put your database in the pod as well. You would put that in a separate pod because it's a different scalable unit. So like think about your pod as that minimum scalable unit of your application, which may or may not contain more than one container. So let's actually get into some demo. And as we do that, I'll show you how the controllers work. So I'll switch across to a terminal. All right, everyone can read that big enough font? Yell if you can't. So first of all, I'm going to create a deployment. It's going to be called hello. I'm giving it an image name, and that is it. So I'll run that, and assuming the Wi-Fi is working, I should get an immediate response saying that it's created. And that's not saying that it actually exists. That's just saying that I've created the desired state. And so now if I have a look at what's running, and I have an alias of K for kubectl, so I'll mostly just type K here. So here we see I have actually three things running based on that one command. And so this is because of the controllers and their actions. So when I create a deployment, the deployment controller picks up what I asked for and performs the action. And the deployment controller handles the life cycle of your application. In this case, because I haven't specified any number of replicas, it's assuming I only want one of them. And so it's created a replica set. And that replica set is sized to 1. And then that replica set then goes and creates a pod. And so there's kind of that 3 layers of indirection. But that gives me some resilience. So I can run a scale command. And I can say I want 3 replicas. Or I can say I want 6 replicas, whatever I want. And then I do that get all again. And we'll see we have a bunch more pods running. But we still have 1 deployment and 1 replica set. So you can see my deployment has ready 6 of 6, replica set ready 6 of 6, and I have 6 pods up and running. Now I'm going to pick this oldest pod here, and I'm going to delete it. So that is, deleting a pod. And so what you would think would happen here is that I would now have 5 pods running instead of the 6. But what actually happens is because I didn't change my deployment, I didn't say I only wanted 5, the deployment is going to see there's only 5 running, and it's going to immediately start up a new one. And so when the I guess, 12 seconds I've been speaking, it's created that new one, and so there's already 6 running again. So the deployment and the replica set work together to ensure that there's always 6 running. Usually it wouldn't be a human deleting a pod, it might be a worker node having a failure or something else happening. And so we get that resilience. We always get the number of pods running that we asked for. And so that's super useful. Now, I mentioned the deployment does lifecycle management. So say we wanted to upgrade our application or change a configuration. So here we're going to actually edit the desired state of our application, and we're going to change something. So here we have our container spec, and I'm going to add an environment variable. Hopefully I remember the syntax. And I will save that off. And I did remember my syntax, so that is done. And so now if I do a get all, we'll start to see some interesting things happening. So you can see I now have a bunch of pods being terminated and a bunch of new pods running. And you can see down the bottom here, I have 2 replica sets. And so what's happening is because I told the deployment I wanted 6 copies of my application running, and then I changed that application, because the containers, the pods are immutable, it creates a new set, but it does it in an interesting way. It creates a new replica set of size 0, and then it adds 2 to that replica set and removes 2 from the old replica set, and it cycles through those, always making sure that at minimum there is that 6 pods running, because that's how many replicas I asked for. So basically, I get this rolling upgrade of my application without me having to do any work. So as long as your API contracts and everything are correct in your application, we basically get a 0 downtime, 0 effort upgrade of our application, which is super useful. Back when I used to do like Chef or Puppet, I would have to write hundreds, if not thousands of lines of the Chef DSL or the Puppet DSL to actually make that happen, and it still wouldn't work that flawlessly. So that's an incredibly powerful thing that the platform that Kubernetes has decided is table stakes, and it's just going to do it. And so that's super useful. And that's why usually when you're creating a workload, you're going straight to creating a deployment. You don't create a pod, you don't create a replica set, you just create a deployment, and you let it manage replica sets and pods for you. Now, you can see here, there's no obvious way to access my application. And so there's a few things I can do. I can do a port forward, and a port forward will just forward a port from localhost directly into a specific pod. And I think I'm on 8080. And so this is great if I'm just testing something out, because I can just quickly test, make sure it's working, localhost 8080. And you can see there's the response, and you can see that's the environment variable I set earlier. So that is kind of proof that the replica set, the deployment did its job, and it's also showing you how you can access your application. But you don't really want to tell the entire world to run a kubectl port forward in order to access your application. So we need to do something a bit more interesting. So we create a service. We can create a service using the kubectl expose command. So you can see I'm doing kubectl expose. I give it the deployment name that I want to expose. And I set a type to load balancer, and then I set a few ports. And so I'll hit enter on that. Again, it will very quickly say it's done. So now if I do a get all, we'll see a new resource, which is a service. And you can see its type is load balancer, and it has a cluster IP, and it has a set of ports. And it's waiting for an external IP. So what's going on is when you create a service, it creates a cluster IP, which is actually a load balancer inside of your cluster that is only available inside of your cluster. And so anything else running can use that IP address, or can even just use the name hello in DNS, because services also manage a DNS server called kubedns. And so anything running in Kubernetes can access this by simply going to the host name hello, which is really powerful and useful. But that doesn't help me access it from the outside world. So then what it does is it sets up a port, which is 31256, kind of out of the ephemeral port range, and it maps that from the external IP address of all of my worker nodes to that internal cluster IP. And so now if I know the IP address of one of my worker nodes, and that port number, I can now access my application from the outside world. But that's still not great. You still don't want to be giving out IP addresses and ports. So when you use a type of load balancer, it will actually go out and configure a load balancer on your cloud. In this case, it's Google Cloud. And it will pass it the node ports, sorry, the IP addresses of the worker nodes and those ports, and will automatically load balance it for you. If a new worker node is added or deleted or the ports change, it will update the load balancer with that information. So I get this fully managed load balancer. So if I do, let's just do a get service. And hopefully we do have an IP address. And so I can go ahead and pump that in. And because I specified port 80, it's going to handle that for me. And so that is my application running out on the internet and available to all. All I need to do now is add some DNS to that. And I can actually use Kubernetes to do that for me. There's an external DNS controller, which will actually automatically register DNS for you when you bring up a service. So I don't even have to worry about that, which is super useful. So that's kind of how you create an application and how you expose it to the outside world. So that's pods and services. Next, you have volumes, which is just a directory that gets mounted into your pod. All of the containers in a pod, I should say. And it usually lasts for as long as the pod does. You can use a persistent volume, which actually outlasts a pod. And so you can take a persistent volume and tie it to another type of resource called a stateful set, which is like a deployment, but is a bit more structured. And you then have a place that's pretty safe to run stateful applications, like a Cassandra database or a Mongo database. You can also mount volumes from config maps or secrets. So config maps and secrets are key value pairs that are stored in a Kubernetes manifest. You can create them from a literal string, key and value, or you can create them from a file. If you create them from a file, the file name becomes the key, and the content of the file becomes the value. And so it would look a little bit like this. So you can see it's index.html, and there's an HTML page. So I could pass that straight into like an empty Nginx image, and I would have an Nginx image that has a static website. Not super useful, but interesting for just demo perspective. Normally, you would pass in like a config file or something like that. And you can also mount these as environment variables. You probably wouldn't mount a file as an environment variable, but if you have like database connection strings, you could mount them in as environment variables into your containers instead of as a file. And then as long as your application can read those environment variables to configure itself, that's how you can pass in usernames and passwords and stuff like that. I mentioned secrets as well. They look exactly the same as a config map, except you can't read that index.html file, right? It is not encrypted. It is base64 encoded, and that's because you can have binary secrets such as keys. If you want to encrypt a secret properly, there's some integrations with HashiCorp's Vault and a few other things you can do, but it's not yet natively encrypted in Kubernetes. That will come pretty soon, I hope. So that's config maps and secrets. So that's kind of a very quick introduction to Kubernetes, and that's just enough information that you could probably run most Java apps, any kind of app that you want, because you can run a binary, you can expose that with a load balancer, and you configure it with config maps as files or environment variables. So that's really all you need to run a basic application. Next is Spring Cloud Kubernetes. So Kubernetes has all these interesting primitives that we didn't necessarily have easy access to before, like service discovery, because we know that as long as we know the name of a service, we know how to access that service because it's just simply the DNS name, right? So we get all these interesting things. And so the Spring Cloud team is like, well, let's expose these into Spring Cloud, and then we can look at removing things like Eureka and whatever else we need for service discovery. We don't need a config server anymore, stuff like that. So kind of what you get when you use Spring Cloud Kubernetes is you get service discovery, you get ribbon discovery for client-side load balancing, you get a dynamic config server, you get automatic profile configurations. If you have a Kubernetes properties file in your application, it will automatically load that because it knows you're running it inside Kubernetes. And it knows about service meshes and also will provide pod health to Kubernetes so that if it stops responding, Kubernetes will actually see that and will terminate and create a new pod based on your deployment structure. So that's pretty useful. Here is kind of an example of a like client-side service discovery. You can see I kind of have my files jammed together, but I've got my pom.xml at the top, and then my actual application. It's pretty simple, doesn't require a lot of work. And then here's what you do for if you want ribbon discovery. And this here is the entirety of an edge application that will load balance for the other microservices inside of my application. That is literally all I need. So it becomes super powerful because it's going to look at the services that are running and create the appropriate routes as needed. You can also, there's two modes for service discovery. One treats it like the old school service discovery, like we expect with the Netflix tools. The other one just simply uses the native Kubernetes, like DNS-based. It also works as a config server. So again, here's your kind of pom.xml. You can see I've got the Spring Boot starter actuator because I need a refresh actuator, and then Spring Cloud starter Kubernetes config. And so with these in my application, and then I can configure my application to look at one or more config maps. And it's going to use Kubernetes config maps as a config server. And so now I don't need to run a separate config server. I can just simply modify a config map. And because it's being used as a config server with dynamic refreshing enabled, I don't even have to restart the pod. I don't have to bump the deployment. It will simply refresh the part of the Java app that is needed. And then not part of Spring Cloud Kubernetes, but definitely worth mentioning, is the Micrometer Prometheus endpoint. So all you have to do is add this to your pom.xml, and you will get automatic Java metrics in Prometheus with no extra work. So Prometheus, when you run it inside your Kubernetes cluster, is looking for applications with certain annotations and certain endpoints. So by having the /actuator/Prometheus in your application, Prometheus will see that and will start scraping that for metrics. And so I don't do any work, and I get those metrics. And so that kind of looks like that when you look at Grafana. So that is pretty useful. So I thought I would do some quick demo now showing that. So let's change to my shop. So you can see here I have an app with 4 microservices, kind of emulating a shop. And I actually have Chaos Monkey enabled on this as well. So if we're lucky, we'll actually see that take effect. So nothing too exciting here. This is my base POM. I've got a bunch of dependencies. And then I have some plugins for doing builds. So I'm enabling the Jib builder, so I can use the Google Jib, as well as I believe I've got the Fabricate Docker Maven plugin, so I can build images that way as well. So I've got like 3 ways I can build build images for this application. Then one of my microservices, which is the one we'll be looking at, is called Fashion Bestseller. And so you can see it has Spring Cloud Starter Kubernetes, config map, and then also the Micrometer Prometheus. And then here is my application Kubernetes.yaml, and that contains basically the minimum configuration I need to run this in Kubernetes. So you can see I'm enabling all the Spring Cloud Kubernetes bits, making sure the management endpoint for restart is enabled, and I'm disabling Eureka because I don't need it because we're using Kubernetes to handle that for me. And then I'm just making sure it's going to trust my Kubernetes certificates because they are self-signed. So pretty simple, and just the act of running this inside of Kubernetes is enough for it to automatically load this properties and set the profile to be Kubernetes. And then finally, if we have a look at my app, you can see I have a couple of beans, the refresh scope, and then I am setting a value with some defaults, right? So I'm pulling a list of products. If I don't have anything set in a config map, it will just default to those. But if I have a config map, it will read that from there instead. So now we can have a look at Let me just paste in so I get the port right. So we're now looking at the gateway application. So that's using the server-side, the client-side ribbon discovery to forward for my application. And so now I have a couple of endpoints we can look at. One is a fashion endpoint that'll tell me my fashion and what my best sellers for fashion are, which is actually just pulling from a config map. And you can see I obviously have a config map sitting there with those 3 items in it. And then I also had, I think, a toys one. So very similar, the best-selling toys, not too exciting. So let's have a look at my config maps. You can see here I have a fashion bestseller config map. So if I edit that, I can do 2 things. I can enable Chaos Monkey. 1 second. That's telling me it's lunchtime, but I won't be too much longer. So we are in Singapore, and so we dress up pretty fancy here. So we're going to have fancy pants, fancy shirt, and fancy socks. And so that is it. I've edited the config map. And so if I then look at my fashion bestseller again, you can see it's immediately updated with the changes from my config map. It happened really quickly because nothing had to reboot, nothing had to be restarted. It just refreshed that part of the application. So if we look at our pods, we can probably even see that happening. So fashion bestseller. So we run this logs command, and that's going to show us what will happen. And you can see right here, it's sort of saying that a change was detected in the config map, and it refreshed the application, and it all happened in no time at all. Now I'm only running 1 pod here, so there's a chance there might have been a slight blip. So in production, you'd probably run 3 or 4 replicas, and that way there'd be it would be a lot better. Now let's see if we can get Chaos Monkey to fire. Sometimes it's pretty random, so sometimes it works quicker than others. Okay, it's not going to happen for me, and we're low on time. So what should happen here is every once in a while, it should fail to load. So it should hit the circuit breaker, which would just provide an empty list. But I'm going to give up. All right, we're not going to Chaos Monkey today. That's fine. So I think that is about all I have. I could talk for a lot longer, but I am pretty hungry, and I'm sure you are too. So we'll call it quits there. So thanks so much for listening to me, and hope you learn a little bit about Kubernetes and the various Spring integrations. Thank you.